Hi, so I'm Pawel. As you can see, I'm by this wonderful design and this Millennium Falcon, and like that I am a fan of Harry Potter, but of course it's Star Trek, but no one probably knows that. Anyway, so I'm here to talk about oracles, the Oracle Directive, as I call it today. And the Oracle Directive is mainly connecting different things, connecting the blockchain with the rest of the world. So what are oracles? The main thing the oracles do is they turn gossip, unreliable data, like unverified information, they turn it into fact. Fact is something that you can trust, something that you know is true, and something that can be used to do other things. And then, of course, you make it available on-chain. I mean, you see what I did there. You make it available on-chain. And this is available to any smart contract that wants to use this data. And I'm always emphasizing that it is very important for the data to reside on-chain, on the same chain that your protocol is actually. So to summarize this part, like Oracle, it's getting external data available to smart contracts during transaction execution. Not before, not after, exactly in the time that you need it. Why are oracles? This was Drax, but never mind. Why are oracles? Like, why do we need them? So they are intrinsic to the DeFi. Like, there is no DeFi without oracles, because oracles are the only tool, the only systems that can put the data on-chain, and everything that does that is actually an oracle. But you could say that I am an oracle when I make a transaction and write a number or a sentence in a smart contract, but like I'm not a really reliable oracle. So how do we do oracles? It seems simple. Oracle systems seem simple. They collect data because blockchains do not see anything besides themselves. So they need something like oracles to collect data from the real world, or like from other chains or exchanges, and like weather data. If you need, like, I don't know if you need weather data on chain, because what are you going to do with it? Like, I don't know. But still, they collect the data, they sign it, so they make it verifiable. They make sure that like everyone else can check, okay, this is someone I trust, they signed it, and then they store the information on chain. And first oracles were also very simple, but like one actor is not enough. If only I am running a node that creates the Oracle node that creates the data on chain, that's not reliable. What we can do, we can have multiple nodes, multiple organizations, multiple parties, collect the same data and store it on chain, and then we can choose or like calculate out of that the proper value. So for example, for prices, what we do is we take prices for the same asset at the same point in time, and we do a median out of that. The median is very good because any outliers that we have in the set, they do not affect the final value, because it's only a selection of the value in the middle. That's why median is so powerful in contrast to average. When you calculate an average, every value adds its impact into the final value. Median is simple. Order everything ascending order, for example, and take the middle value, and that's your median. But this is right now on L1s and actually everywhere else. This is expensive because the storing happened in Oracle's version 1. The storing of data happened separately for everyone. That means you have to have 3 or 7, or how many you want transactions to put the data on chain and create this final median. So the next thing oracles did, and we did in Chronicle, oracles created a peer-to-peer network. When we created a peer-to-peer network that collects data from different signers, but as you can see, the storing of the data happens only once, because if the data is signed, then no one can manipulate this. Like if they did, we would know, like everyone would know, and it's public. So we've got this data, and we calculate the median off-chain, and we create the transaction, put it on chain, and what the contract does only, it just verifies if the value was is a median, because if you have all the values, you again sort and select the middle value. If the middle value is what you want, or what was said that it is, then it's fine. If it's not, then too bad, it's not going to be published. But of course, with the gas also going in price, right now it's super cheap, but there were times that the gas cost 200 gwei. That's unsustainable for anyone. So we in Chronicle, we introduced a third type of oracles where we use signature aggregation. We use the Schnorr scheme to do it. So we managed to take all of the signatures, because in version 2, you needed to verify every signature separately. If, for anyone who knows smart contracts, it's a easy recover, 3 times or 13 times or something like that. And here, you can verify it, you don't have to provide all of the signatures with signature aggregation, because all of the 13 signatures, 13, that's the number we use, because we want to be sure that it's actually accurate. So 13 out of 25 is a good multisig, because that's a multisig. So we take those 13 signatures, a lot of cold data, we compress that with Schnorr signature aggregation into one signature. And then the smart contract, the transaction, when it's sent, it has only one signature, so it saves us a lot of gas. That's for starters. The next step for optimization that we did is that we create optimistic updates, which means that we can optimize for compute cycles. So the optimistic update allows us to do less computation, but we need to make sure we can verify the data if it's wrong for some reason. So there's a challenge bounty included in that system that you can ensure that the data was correct. And afterwards, if you detect a bad signature or a bad update, you can take the bounty, which is 1 Ether on every oracles. And this is the explanation with the images. So we have data, and we normally verify every signature separately, but this is very expensive. And then we can aggregate the signature. It is still expensive, but it's not as expensive as it was before. But here, when we do an optimistic update, one of the validators, the data nodes on the left, so one of the validators says, okay, I see this complete signature. I see those signatures from 13 validators, and I'm going to vouch. I'm going to use my signature to say, I see it, it's okay. And then it's super cheap for us to do an update, because the first step is to send it to the contract, but it's not yet the proper price. We have a challenge period of a few minutes, 20, 10, depends on the system, but we have a challenge period in which the value is not yet considered stored, it's just pending. And then in this time, you can create your own bot, or you can do it manually if you want. You can see, okay, this signature here doesn't compute. I see someone said it's okay, so I can use this information because it's all public in the logs from Ethereum. You can use this information and challenge, accept the challenge, and what happens is this data doesn't get propagated into the smart contract. It gets reverted. Like, it's not even going to get reverted to the previous price. Like there's nothing. It's like the update never happened. But at the same time, we are banning this actor that created this bad authentication, like signed this bad multi-signature transaction. And what happens as well is you get some Ether. So that's how we protect the system. And this is wonderful because with this, we can scale the number of validators theoretically infinitely, but the thing is that it is very important when you are using oracles, it's very important that you know how many signatures for a multisig you need. Like the oracle needs to have to do an update. So there are some oracle systems and oracle providers that say, okay, 4 out of 9 is fine, but it's not. And the biggest problem is when you don't know who those 4 are, because actually it could be one person. So with an optimistic update, we can scale the number of validators, and only when there's a problem, we can verify. Okay, that verification is going to be expensive, but still, you get the bounty, so it's a win-win for everyone. We protected the funds, and you got the bounty for this challenge. Where are oracles? So you can check out our dashboard at chroniclelabs.org/dashboard, or like go to our website, chroniclelabs.org, and you can see how many oracles we have. There's a mainnet version, and there's of course a testnet version, so you can you can play with this and verify yourself to be able to do the updates and so on, and like join the system to read the oracles. And what you need to remember is that your protocol, like anything that you do, if you issue loans or like do something else with the data, your protocol is only as strong as your weakest link. If something, like if you have a super robust system, but you use a bad oracle, then I'm sorry, your funds will be stolen. Like recently, there was an incident with an oracle provider whose name I'm not going to say, but you can Google it. And like there was a bad price in the oracle, and the money went poof. Of course, it's not really their problem because it's the data source that was responsible, but still, like they didn't have a system to verify if it's actually what it should be. So know your oracles, or be another article on Rect. That's super important. I wanted to talk about the properties of oracles that you need to look at when you are trying to choose an oracle provider or like build a system. Because when you build a system, maybe sometimes it is okay for you to use one of 2 multisig for your funds. Maybe that's fine because there's not much money in there and like you're fine with it. But what's important, it's not that it has to always be super like complex and secure. It needs to be adjusted to what you actually need. So you need to take into account the risks that come with using any module. Oracle is one of the modules in systems. Any module in your protocol. So for accuracy, it is super important to look at an oracle provider and oracles in general to see how many sources are there on this on the start, like on the left side, your left, like there was the data. So you need to check how many independent sources were queried for this data, how the data is modeled. Is it a median? Is it a median of medians of medians? Or is it just one source, or is it 5? And are they actually independent? Are they public? Or is it like some number, like, I don't know, out of thin air? And also, you can check, as I said, with median, the one source doesn't affect the outcome. With average, it does. That's the problem. And how is the integrity preserved? So what's the signature scheme? What's the signature type? And what's the, how many signatures do you have on the multisig? Then, consensus. How is the truth determined? So that means if we have a peer-to-peer network of data providers in an Oracle system, like how do we decide which value is correct? That also touches on the median, because like in our systems, we have a median on the validator side and a median in the model itself. So the data is a median of medians, which is quite secure. We never had a problem with that. And we have been around for since 2017 because Chronicle was part of MakerDAO. You might know it as Sky right now, but Chronicle was part of MakerDAO, and we've secured with this is the same team and the same software, also of course developed to be better in time. The same software that was protecting MakerDAO, and this is a super OG system that works until today. Availability. This is super important when you think that some Oracle providers have so-called pool oracles. So they put the data somewhere in an API or on a different blockchain. And then when you do a transaction, you take this data from that source and use this data to update the Oracle and do the transaction. But what happens when this source gets lost? It is because of that, it's very important that the protocol that you are and the chain that you are on, your protocol is exactly on the same chain as the data. So the Oracle is a smart contract on the same chain. So if the blockchain is broken, we have bigger problems. Everything goes to shit. But assuming the blockchain works, you are fine and you are safe. So that's super important to look at, like, what's the data availability aspect of the oracles. And the cost. In pool oracles, the problem is that the cost of update is not on the protocol side, it's on the side of the users. So it's actually a tax, a bad word in crypto, a tax on users. So I personally do not recommend pool oracles for systems that have users and a lot of detail users, because like you're just taxing them. You're just making the transactions more expensive for them. And about the cost, of course, there's the aspect of scaling. As I said, we have oracles and the updates that allow us to have like 200 validators. So it's like super robust value, and have like super low price for your protocol to use this oracle. So this is like a no-brainer. Transparency. Yeah, that's a big issue. Because in Chronicle, the Oracle provider, the data providers, the validators, as we call them, they are reputable projects. They stake their reputation. They stake their reputation to make the update, to say that this data is correct. If this data wasn't correct, for example, let's say ETHSofia did something wrong and gave us a bad price, then like their reputation is something that they value very much. So that's super important, and you need to look also at the data providers. Permissions, who can change the parameters, who can do the update, that's also super important. And whenever something bad happens, or whenever you are planning for something bad to happen, what you need to look at is how probable is this thing that can happen, and what is the impact, how big is the impact. Because sometimes maybe you can like play and tweak the risk parameters on your protocol, according to some factors. And all of that factors actually, at the end, contribute to how expensive your protocol is. So the one thing that is also super important, and it's not found anywhere yet is an independent verification metrics and tooling as a public good. Why as a public good? Because it doesn't it cannot be compromised by someone paying, okay, you say our protocol is fine and we're going to pay you money. No, that cannot happen. So it needs to be public good. It needs to be crowdsourced and it needs to be credibly independent. I am not credibly independent because I work for Chronicle, but I really am passionate about that, and I would support it with all my heart and skill if someone started on, let's say, L2 bit for oracles. I hope you have heard of L2 bits. It analyzes layer 2s, and it says that most of them are shit, but, well, that's true. And then, if we had something for oracles, that would be a game changer. And it is really, and it should be somewhat automated, so you can just get the inputs, do the calculation, and the application would show you, or like the code would show you, okay, this is bad, or this is good. Main thing I would like you to remember, do not trust, verify. Always verify. When someone tells you, oh, we are going to select a very good strategy for you. Yes, show me the code. Like, never trust. Right now, as you can see, like, you cannot even trust your browser, but that we actually knew. But you cannot trust your computer. I think we also knew that. You cannot trust AI. I don't know how it's going to be because, like, it's not Skynet yet, but who knows. So yeah, I am Pawel. I work at Chronicle. I'm also a co-founder of ETHSofia. And if you would like to know more, go into our website, find us on Twitter as well, like the Chronicle Labs, at Chronicle Labs is our Twitter handle. And I do hope that I helped you understand the oracles a little more. Yeah, end transmission.